Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn potentiometer. It is a versatile instrument. It is used for accurate measurement of potential difference, current and resistance. We can easily compare the EMFs of two cells and also we can calculate the internal resistance of the cell. Look at the diagram. It consists of uniform wire of length 10 meter arranged between A and B as 10 wire, each of length 1 meter on the wooden board. The free ends are brought to the same side and fixed to the copper strips with binding screws. The wire is made up of manganese or constantan. Jockey can be moved on the wire. A meter scale is fixed parallel to the potentiometer wire so that we can easily measure the balancing length. See, here I have 10 wires. Instead of 10 wires, I have drawn single wire, that is CD in this circuit. Here battery, key and this potentiometer wire CD are connected in series. This forms primary circuit. The positive terminal of the primary cell of EMF Xi is connected to C end. The negative terminal of the primary cell is connected to jockey through galvanometer and high resistance. So this forms secondary circuit. You know that when steady current passes through the uniform wire of the potentiometer, the potential difference across any part of the wire is directly proportional to the length of the wire. This is the principle. Here the steady current is maintained across CD by this battery. How do you measure the balancing length? Just move the jockey on this potentiometer wire. At some point the galvanometer shows null deflection. Say that point is J. So Cj is nothing but our balancing length. There is one important condition. If the potential difference across Cj is equal to the EMF of the cell, then no current flows through the circuit and the galvanometer shows null deflection. Then only we can measure balancing length. How do you calculate the resistance across Cj? That is R into L. What is this R? Resistance per unit length. Already studied in meter bridge explanation also. Next I am going to calculate potential difference across Cj. That is V. According to Ohm's law, you know that V is equal to I into R. Here I is nothing but current. Instead of R, you substitute small r into L. That is our V. We know that if the potential difference across Cj is equal to Xi, means galvanometer shows null deflection. So instead of V you can write Xi. So Xi is equal to I into R into L. This I is current, R is resistance per unit length, L is balancing length. So Xi is equal to IR into L. I is constant, R is also constant. From this equation, we can conclude that the EMF of the cell is directly proportional to the balancing length of the wire. In this class, we discussed about the construction and the principle of potentiometer. Then we concluded that EMF of the cell is directly proportional to balancing length of the wire. Under which condition potential difference across CJ is equal to the EMF of the cell, then no current flows through the circuit and the galvanometer shows null deflection. Then only we can measure the balancing length L. So Xi is directly proportional to L. The EMF of the cell is directly proportional to the balancing length of the potentiometer wire. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.